In this video, I want to talk about second partial derivatives. So we're given some function here, and I've got a couple problems. I have like A, B, and C. Okay. So what we're going to do is we're going to say, what does this mean? If I say find d squared z over dx squared. No. Remember in calculus 1, we said that's not really squared. This is the second derivative of z with respect to x 2 times. So what we're saying here is, remember in like calc 1, if we found the second derivative of x, right, we'd say y prime equals 3x squared. So that's the first derivative. So you just do the derivative of your derivative to get your answer, right? So what are we going to do here? Well, this is the same meaning. So we're going to do the derivative of our function 2 times. That's why it's the d, like the little 2 up there. So we're going to use this function twice. But you'll notice, like if you compare this denominator with this denominator, that's kind of your instructions about which variable you're going to, which thing you're going to think of as a variable. So in this one, we're going to think of x as a variable twice. Where this one, our first derivative would be with respect to x, then our second derivative would be with respect to y. So let's do these. So the first one, we're going to find our derivative with respect to x. What would that look like? Well, remember, if x is our variable, then everything else is a constant. So therefore, I'm just thinking of this as 7 times do the derivative. So therefore, let's get rid of that highlight so I can use it later. Okay, so the 2 is going to come out to the front, making it 14x to the first y cubed. That would be our wrong d. There we go. dz dx. Our first derivative would be 14x y cubed. Right? But now we have to do another derivative. So how do I take this and turn it into the second derivative with respect to x 2 times? Well, we're going to look at this and say x is our variable again. So therefore, the 14 is a constant, the y cubed is a constant, so the only thing I'm doing as a derivative is the x. X to the first, well, that would become 1. So that leaves me with 14y cubed. And there we go. So that one leads us to this. Okay, now I'm going to borrow this. You come down here. All right, so now, next problem. How are we going to do the second derivative of z with respect to derivative of x, then the derivative of y? Now, this is the order. First, you do this one, then you do this one, right? So how would I do this? Well, I'd say dz dx, right? The partial derivative of z with respect to x. So we already did that problem, right? It's just 14, whoops, that's a 7, 14xy cubed, right? So now, how do I get to this? Well, I need to do the second derivative. This function here, we're going to take our answer. But now the second time we do it, y is our variable. So 14 is a constant, x is a constant. So therefore now, the second derivative of z with respect to, we already did with respect to x, but I can't write a squared here because I'm not doing it twice. Now I'm doing the derivative with respect to y. So let's see, the 3 would come out to the front, making it 14 times 3. Let's see, that would be 42xy to the second. And there we go. So there's a second derivative of z, first with respect to x, then with respect to y, the partial derivative. So that brings us to our last problem here. And now at this point, I'm hoping you've got this. This is no big deal. And you're just going to say, let me pause the video and do it myself. So what does this notation mean? What is that saying? Okay, try it, pause it, come back and see me. Okay, I'm hoping you tried it at this point, so here we go. We can't jump straight to the second derivative, we have to stay with the first. And so first we're going to do a derivative with respect to y, so going back to our original function, which was up here. Here we go, I'm going to pull this down. If you don't do sound effects, it's not fun, okay? You got to have the sound effects. Okay, so the derivative with respect to y, so therefore the 3 is going to come out to the front because the 7 and the x squared are constants. So the 3 comes out to the front, making it 21x squared y squared. Now, to get our second derivative, because we want second derivative with respect to y, we're going to just do it again. So it's going to be the second derivative of our function with respect to y 2 times. So once again, the 21 and the x squared are constants, so they just stay there. The 2 comes out to the front, making it 42x squared y. Okay, I hope that helps you get comfortable with second derivatives. And something I want you to think about when you're doing your homework. You will notice as you're going through, I want you to think about this. Does the order matter? Look at doing the second derivative with respect to x, then y. Then look at doing the second derivative with respect to y, then x, and compare your answers. See how that all works out. All right? Good luck on the homework.